Okay, before we get into doing stuff together, I wanted to just go over something with you. Um, Maybe this is more review than anything else, but I did want to kind of make sure that you were familiar with this. So let's see how well you follow my language. Okay, so I have up here, you can see two adjacent angles. They're unequal adjacent angles, which means they're not right angles, right? I've got one angle that's acute and one angle that's obtuse. Can you find both of them right now? Okay. All right. Now, um, today we're going to be moving into the analytic side of our angle evaluation. So we've been talking about angles in terms of comparison to each other, right? Like acute angles are smaller in size than right angles, where obtuse angles are greater in size. Now we're going to put numerical measurements to those. And so Formative has a cool little protractor tool that we can just pop up here on the screen like that. And so I wanted to make sure you were familiar with this tool and how to use it. Okay, so a couple things to know about this. Obviously, you can see this is half of a circle. If I took another one and flipped it underneath it, right, I would have an entire circle. And you see all these little lines that go around the circle, right? It's just like a ruler. Like we have centimeter measurements and millimeter measurements and inches measurements on our ruler, so we can measure our line segments. Well, we have little measurements of our angles across there. What are each one of those lines called? What's the unit of measurement that we use for circles? At least on this tool. No, not radiuses. No, not diameters. Degrees. There you go. All right. So degrees. So when we talk about a degree, what we're really talking about is just like a centimeter or a millimeter. It's a unit of measure around the circle. Okay. Now that's all of the little marks right there. And this actually goes way back to like ancient civilizations. This goes back to like Babylonian civilizations when they used a base 60 number system. This is where we get like 365 days for a year, right? They estimated it about 360 days. They were watching the sun move through the sky in a semicircle, and they were counting how long this took, and they were tracking this information with the stars, and that's how they came up with these measurements. This is kind of just stuck with us all that time, okay? So what we're going to do is we're going to use this tool to put a numerical value on our angle size opening. All right, so let me show you how this works. This intersection that exists right down here at the bottom, we're going to take that intersection, and right where those two line segments meet right there, we're going to make that the vertex of our angle. So you're just going to take this tool and you're going to drop that little intersection right down here on the vertex of your angle. Get that right on there. And then where your line goes through, when you look at the opening size, that will tell you how many units of measure around this circle the size of that opening is. So you can see on the right side here, this side, the acute side, this opening is tick, 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 60 units of measure around the circle, or 60 degrees of an opening, okay? So when we talk about the angle size, now we can put a measurement on that. It is a size 60 opening. Now you'll notice that there's two sets of numbers on the protractor, right? So then the question becomes, well, which number do I use? Because really this line goes through the 60 and through the 120. And this is where you have to rely on your understanding of acute versus obtuse angles, right? So acute angles are less than right angles. We can see that straight up and down line here. That's our 90-degree angle. So if we're dealing with an acute angle in this measurement, we're going to use the smaller set of numbers. We're dealing with an obtuse, we're going to use the larger set of numbers, right? And so you can see on the right side of these adjacent angles, this is going to be 60. Well, when we measure the obtuse side, that's where we're going to use the larger set of numbers. That becomes a 120-degree angle. So we can measure two different angles here because they're adjacent at the same time. 60 and 120 add up to what? 180, right? 180, and that is halfway around our circle. So if we were to take and count all of these degree measurements all the way around, we're getting 180 of them. And of course, if we have another one on the bottom, that's where we get our 360 degrees in a circle, okay? So it's actually units of measure all the way around the circle. Okay, now one other thing I want to show you with this tool, you don't have to just line it up like the way it looks right here. You can put this intersection at any vertex, and you can line this baseline here up along any side of your angle, right? Like when I did this here, I lined the baseline of my protractor along this side of my angle, but I could take my protractor and I could turn it, move it in here a little bit closer so I can see if it's lined up. I think that looks pretty good. So I can turn my protractor like this. Now I'm going to take this baseline of the protractor here. I'm going to line it up on this side of my angle. I'm still going to put my vertex in the same spot. And when I move my vertex down here and I put it in the same spot, you can still see that it's measuring the obtuse angle at 120 degrees. But this time we're using the 120 that's on the inside track. You see that? So you got to pay attention to where the vertex is, but most importantly, are you measuring an acute angle or an obtuse angle to determine which one of those sets of numbers? You can't always just say, well, I'm just going to use the numbers on the left or I'm just going to use the numbers on the right. It depends on how you position your protractor. And so keeping that in mind will make sense. Questions so far? Everybody good? Easy enough? Okay. All right. So here's what we're going to do. We're going to start with an IXL. Don't move. I want to show you something first so that you don't come up here and start asking questions, because I want to be able to just kind of troubleshoot that a little bit ahead of time. So let me show you what the IXL is going to look like so that you're familiar with it. Okay. So one type of question that you're going to see is this one. Very straightforward, very similar to what I just showed you. You can see one of your sides of the angle runs along the base or the zero line of the protractor. All right, let's try that again. So one of the sides of your angle runs along the zero line of the baseline, and then it just comes out of here. And so you can see that this is acute or obtuse. Which one? Obtuse. So what's the degree measure on this one? 150 degree angle, right? Okay, so that's one type of question you're going to see. That's a real basic one. Now you got this one. Now notice that the baselines or the sides of the angle have shifted a little bit, right? So they don't run necessarily right along the zero. But if you imagine if this side did run along the zero, that would be a 160 degree angle, right? But it doesn't. It shifts up 5 this way. So it's 5 less than a 160 degree angle, or how much? 155 degree angle. Okay, so that's one type of question you're going to see. Now, the next type of question you're going to see is an estimate question. This is not, I want you to take out your protractor, put it up on your screen, and try to figure out what it is exactly. This is, I want you to kind of ballpark it. So based on your understanding of this picture right here and knowing where those numbers sit, is this, first off, acute or obtuse? Obtuse. Okay, now give me an idea of what you think this might be. 50? That wouldn't be obtuse, would it? 100? 130? What's that? 105? Okay, all right, so this is what you're doing. You're taking a guess at this, okay? And here's the goal. The goal is for you to get within a range of margin of error of 15 degrees on one side or the other, right? So if you say 105, right? I'm just using yours as an example. You say 105. What you're saying is that's got to fall in the range somewhere of 120 to about 90, somewhere in that ballpark. You're trying to fit it in a range of 15 degrees on either side. Does that make sense? So again, the more accurate you are with your guessing, the better that you're going to be. This one's probably going to run in the range, I would say, of closer to 120 degrees, something like that. But again, as long as you get it within a 15 degree area of measure, and then as you get a little bit higher, it's going to narrow the window for your estimates. Okay, so again, you're kind of estimating what you think this is, and then you have a little margin of error on either side of that angle. Okay, does that make sense? Yep. Okay, all right, we're going to crank this to 100. We'll take 5 or so minutes, 6 minutes to do this. It shouldn't go very, very long. So we'll see where we're at in just a few minutes. All right, so go ahead and get this out. I will zoom in here to your shortcut code BCQ. That's the one that you want to use. All right, so now we're in our formative. You should be looking at something that looks like this. You can see there's a bunch of places that we're going to enter some information here. But for now, let's just go to the show your work section. And then I want you to minimize your question answer point so we can come down here and we can talk a little bit about what we've got going on here in terms of our assignment. All right, so you can see here that point D is in the interior of angle ABC. Can you find that in the picture? Point D is in the interior. You had questions like this on IXL. There's a point on the side. Is it in the interior? Is it in the exterior? Point D is on the interior of angle ABC. Let's see how well you speak my language, okay? So by drawing ray BD through point D on the interior of angle ABC, I've now split angle ABC into two parts, angle ABD and angle DBC. Now, those two parts aren't congruent because we don't have any congruency marks in there. So ray BD is not an angle bisector, but it does cut angle ABC into two parts. Did that make sense?
Yes.
Okay, good. All right, you're speaking my language pretty good. All right, so what we're going to be talking about today is we're going to be talking about something called the angle addition postulate. It's not really a postulate in terms of our Euclid postulates, but that's the common name given to it, much like our segment addition postulate. Okay, so you should be taking some notes right now. If you're not taking notes and you're doing something else, then you're missing what we're doing. Okay? All right, so now that we have this ray BD in the interior of angle ABC, then we can make a certain statement. Now, I'm going to write something a little weird here, okay? So I want you to make sure to watch what I write. I'm going to do a little lowercase m here before my angle sign, and then I'm going to say ABD like that. Now, let's talk about this notation. It's important that you understand this. That is read the measure of angle ABD, which is now replaceable like a variable with a numerical value, which we just got from our protractor tools. Okay, so just like we had figure language and number language for our line segments, segment AB had a little line over the top, but just AB meant the length of segment AB, and that was replaceable with a number. This is the number language version of the angle. So if I'm just talking about the angle, like you can see right there, angle ABC, I'm talking about the space in between rays BA and BC that meet at point B. But when I talk about the measure of an angle, now I can replace that with a numerical value, which means I can also do math with it, right? Because it's really a variable, just like I could put X there, okay? And sometimes we'll do that as well, all right? So the measure of angle ABD plus the measure of angle DBC. When I combine those two measures together, I'm going to get the measure of angle ABC. I'm going to take part of the angle and I'm going to add it to part of the angle, and I'm going to get the measure of the whole angle. That should sound familiar to you, right? In fact, that's exactly what this is. Let's rewrite that here. This is part plus part equals whole for angles. So it's the same idea of our line segment addition postulate, where we took part of a line segment and added it to another part of a line segment to get the whole line segment. Now we're going to do it with parts of an angle and other parts of an angle, and we're going to combine those together to get the whole or find a part one way or the other, and you'll see a little example of both of those right here. So now you should be looking at this here. All right, and so you can see this first question. Now, let me just be clear about something when we see these questions like this. I want you to understand that question number 1 and question number 2 are two totally different questions, even though they use the same diagram to reference certain openings, okay? And so you have to keep that in mind. Just like when we're doing algebra and we have an X in question number 1 and we have an X in question number 2, it's not the same X. Okay, they're totally different questions. And so you have to keep that in mind when you're looking at these. All right. So here in question number 1, it says the measure of angle ABD is 48 degrees. Find ABD. See where it is in the diagram? That's 48 degrees. Now find DBC. That's 78 degrees. All right. And what we're trying to look for is the measure of angle ABC. So we would set up a part plus part equals whole math problem to do this. So in a very simple context, we would say that 48 plus 78 is equal to the measure of angle ABC. Part plus part equals whole. Set it up like that every time, and then you can solve the equation. Now, solving the equation in this case is very simple, right? Because I'm going to add my two numbers up. 48 plus 78 gives me what? You guys tell me. 126, right? So I'm going to write it like this. I'm going to say the measure of angle ABC is equal to 126 what? Degrees. Don't forget that. Draw a little arrow here and write super importante. This is very, very important. You will not get the point informative if you don't use your degree marker. All right, so let's practice typing this into formative to make sure everybody can get 1 point. So open up your question answer spot here, and then you're going to click in the measure of angle ABC. Let's see if I can zoom in here a little bit. All right, you're going to find your degree marker on the functions tab, on the F tab here. It's the upper left box. You see it right there? So if you want to type in 126 degrees, you'll type in 126 like that, and then you'll go to your functions tab, and this upper left corner here, there's your degree symbol. And when you put that in, you should get yourself 1 point on formative. I got 1 out of 11. Look at me. Woo! Yay. Did you get 1? Okay. All right. So I'm going to minimize that. All right, now let's talk about the next one. All right, now in the next one, we've got the measure of angle DBC is 74 degrees, and the measure of angle ABC is 119 degrees, right? Okay, DBC, is that a part or a whole? DBC is a part. ABC, is that a part or a whole? That's a whole. Okay, so what we're really doing here now is we're kind of changing it up just a little bit, right? So we're going to go part, which is 74, plus, okay, well, so then we need the other part. What is the other part? Hey, we don't know what it is, right? So we're going to use the other angle. So we have DBC. So what is the other angle that we're going to be making the part out of? ABD, right? Which is the one we're looking for, right? So 74 plus the measure of angle ABD, part plus part equals whole. Okay, well, the whole here is 119. Set it up like that every time, and then solve your algebra. So do part plus part equals whole. It'll make sure you set up the problem correctly. Again, remember, the synthetic part of this is setting up the problem correctly, right? Understanding the relationships between the part and the part combined to give us the whole. And then the analytic part is doing it with the numbers. Okay, now we solve by doing our subtraction. We get the measure of angle ABD is equal to, what you guys get? 45. 45 what? Degrees. 45 degrees. Type it into formative. You should get 2 points. Make sure you get 2 points. Question so far. Everybody good? No, not good? All right, here we go. So let's bring some algebra into the mix now, right? Okay, so we've got the measure of PQR is 141 degrees, and then we want to find some measures over on the side. Okay, quick question. PQR, tell your neighbor, is that a part or a whole? Right now, tell your neighbor, part or whole. What is that? Part or whole? You guys tell me now, part or whole? Okay, that's the whole. All right. Now, if PQR is the whole, then that means PQS must be a part and SQR must be a part. And we want to do part plus part equals whole, right? And we can see that PQS is equal to a size of 13 times plus 4 degrees, right? See the degree marker outside the parentheses there. And SQR is 10 times, same, because it's the same variable, minus 11 degrees. Okay, so why don't you try to set up a starting algebra problem? Let's see if you can get a part plus part equals whole. Because, listen, we got to find the, we can find the degree measures, right? So we got to get an x equals. And if we want an x equals, we got to start with a something equals something. So what are we going to start with? Write it down. Let's see how you do. So moving in the right direction, you should have started here. Part plus part equals whole, right? So part plus part equals whole. And then I'm going to get my line tool so I can keep my algebra nice and neat and organized. And then I'm going to solve my equation. Okay, so solving my equation, right? I'm going to combine some like terms. In fact, here I'm just going to kind of delete these little squiggles now that I know part and part, right? So remember, we're not moving things to the other side of the equation until we simplify both sides. I'm going to combine my like terms. That's going to give me 23x's plus 3 is equal to 141. And then I'm going to minus 3 from both sides. It's going to give me 23x's is equal to 138. And then I'm going to get x is equal to 6, right? How'd you do? 6? Yes? Okay, good. So we can write our x equals 6 what? No, I gotcha. 6 is not an angle measure, so it does not get a degree marker, okay? So I want you to put a degree marker here, and then I want you to put an through it, okay? Remember, 6 is the that we use to multiply and add to other numbers to get our degree marker, right? Like if we wanted to find, I'm going to write this over here, the measure of angle PQS, that's going to be 13 times plus 4 degrees, because that's the angle measure. And I now know my is 6, so I can write that in there. So I do 13 times 6. So 10 times 6 is 60. 3 times 6 is 18. 60 plus 18 is 78. Plus 4 is 82 degrees. Very good. 82 degrees. Now, this brings me to another point. You'll notice that when I'm doing my math, I don't write the degree markers in because it just gets a little sloppy. So I'm not going to worry about all that. I just want your degree markers on your answer. It's just like when we're doing a math problem, we don't write centimeters on every number that we do our math problem with. We do our math and then we put our unit in at the end of our problem. All right, so now we want the measure of angle SQR, which is 10 times minus 1. Put my in there. 10 times 6 is 60 minus 1 is 59. Is that a degree one? 59? Yeah, because that's an angle measure, right? I mean, it's pretty clear. It says measure of, right? Okay, so that's a degree one. All right, so I want you to get your answers typed in there. You should have a total of 6 points on formative. I'm going to come and check and see how we're doing. Get those typed in now. 1, 2, 3, 4. Sorry, 5 points. My bad. All right, so here we have question number 4. Okay, the measure of angle DEF is 7x plus 4 degrees. The measure of angle DEG is 5x plus 1 degrees. The measure of angle GEF is 23 degrees. Find each measure. Why don't you do this? Start by finding all of those names and try to determine for yourself, do you have parts or wholes? Like, for example, is DEF, is that a part or a whole? Okay, that's the whole. So that's the one that's going to go all by itself on one side of the equation. And so that means DEG is a part, right? And GEF is a part. Okay, let's see if you can set up a part plus part equals whole for angles for question number 4. Okay, moving in the right direction, you should have set up your equation like this. Yes? Part plus part equals whole, and then I'll let you do some work. I'll give you another step along the way. All right, solve that, find x, and then the measure of angle DEG and the measure of angle DEF. Okay, solving your equation, you should have got here, x equals 10, yeah? Okay, now listen, I'm gonna give you a tip. I set these formatives up for you to give you instant feedback for a reason. Here would be my recommendation for you. Once you solve for x, if that's the first measure or that's the first value you're looking for, plug that into formative and check and make sure it's right. Make sure you get a point for that one, right? Because it would be kind of pointless to get the x wrong and then go back and figure angle measures off the wrong x, right? So make sure you got the x right first by checking it in formative, and then go and do your rest of your problems. Don't do all your work and then just type them in at the end, okay? So that would be my recommendation. All right, finish that one up. Finishing this one up, here you can see your angle measures that you should have come up with, and then you can check those answers on formative. How are we doing so far? Part plus part equals whole. You get the idea? All right. Okay, what I want to do now is I want to kind of move us forward just to talk about a few things, and then I'm going to give you some time to do some work and get some practice in. Okay, so I'm going to move you forward here off of this question. Okay, so you should now be looking at this one right here. How are we doing? Everybody with me so far? Everybody here? Okay, if you're not, go ahead and refresh your screen. Okay, I want to talk about a couple of things on this paper, but we're not going to actually do the problems right away. So don't just jump in and start crunching numbers, because then you won't be paying attention. And if you're not paying attention, like if you're surfing something else right now, then you won't be focused on what we're doing here in class. Okay, all right, so it says here that angle DEF is something that we call a straight angle. Now find angle DEF on here. Yeah, it looks weird, right? It doesn't look like any other angle that we've seen before, right? In fact, if you kind of think about it, it sort of looks like this. If I took these, like let's say I took these two yardsticks here and I put my fist is point E and point D is out here. It's almost like I took this and just kind of opened that angle all the way up until it made a straight line. And that's what it means by straight angle. Okay, and again, this is another one of those sort of modern high school geometry ideas, right? But how many degrees do you think this would be if it went? 180. Yeah, it's a 180 degree angle. So a straight angle is another name for an angle that measures 180 degrees in size. All right, so let's write that down. That's some important vocabulary to have. So I'm going to squiggle that and swoop an arrow up here. Now, some of the things I'm going to show you here in these problems that we're talking about is ways that we say things in questions or in geometry language that puts numbers in your pocket. Okay? So if I say to you, if I say to you angle DEF is a straight angle, that puts a number in your pocket. That puts a 180 in your pocket for you to use. See how that works? Okay? And so knowing what to look for in these questions is important. Okay. All right. We're going to leave that question behind, though, for right now. And what I want to do is take a look at a different one. So let's take a look at this bottom question down here. All right. Now we've got the measure of angle ECD. All right. So find ECD in the picture. Okay. Now here's the deal. ECD is 6 less than 5 times the measure of angle BCE. Huh. Okay, question. ECD, is that a part or a whole? Okay, that's a part. And how about BCE? That's a part. Okay. All right. And then BCD? Okay, that's the whole. All right. So we know that BCD, that's going to go out on one side of the equation, right? That's on the whole side. So now we got to figure out some way to come up with the parts, right? That's the idea here. Now, these types of questions relate one of the parts to the other part mathematically, all right? And so how you're going to do these questions is you always want to start with the other part. Like, for example, look. Measure of angle ECD is 6 less than 5 times the other part. See what I did there? Okay. And so it's easiest to start with the other part, and then we can just take that other part, which is the measure of angle BCE, and we can just call that Because now once we have 12, 18, 22, 19 and a half. Could be anything, right? But what we know is whatever that is, the other one, ECD, is 6 less than 5 times that amount. So kind of like writing an algebraic expression. We did this in our Algebra Smash. We did these questions. All right, if I want 6 less than 5 times some amount, well, it would stand to reason I should probably start with 5 times that amount, right? Because then I can take off 6, right? So then what I want to do for this one here is I want to start with 5 times. Now that I have that, I can take off 6. That's 6 less than 5 times, which is over here. See what I did? I put the responsibility of coming up with the algebraic expressions for the parts back on you now. In the last question, you were given the algebraic expressions for the parts. Now you're going to have to create them based on some mathematically stated relationship between those parts. And you're going to write algebraic expressions to do that. But now that we have them, well, the rest of this becomes pretty easy, right? Because then it's just part plus part, see what it did, equals whole. I got the whole right here. It's 162 degrees. Again, part plus part equals whole. Your job is to figure out what the algebraic expressions are based on the relationship given to you. And listen, if you're unsure if you wrote the algebraic expression, right, just test it. Pick any number, right? Like let's just say 10. Let's say is 10. Okay, well, what is 6 less than 5 times 10? Well, 5 times 10 is 50. So 6 less than that is 44, right? So check it and see if it works, right? And that's a way that you can go back and take your answer and plug it in and make sure that you got it right. And then if you didn't, then maybe go back and double check your algebraic expression, all right? Okay, I'm going to leave you with that one to do a little bit later, but I am going to move you forward here to one last thing I want to talk about. All right. So the last couple questions that we have here, now you've got a diagram that's got multiple angles on it, right? Not just two angles. And so again, you can see it's going to become really important for you to be able to find those angles, okay? All right, now, the question 9 is pretty straightforward. It's just you being able to find the angles. I think we've done enough practice on finding the angles. You should be okay there. But I want to talk about question number 10 just a little bit. So let's take a look at question number 10. All right, now question number 10 reads like this. If ray BD, find ray BD. Find it right now. Where's ray BD? Find it. If ray BD bisects angle CBE, find CBE. If ray BD bisects angle CBE, okay, what does it mean to bisect an angle? Split it into two congruent parts, right? Okay, so as soon as we see that language there, now we know something, right? We know that angle CBD and angle DBE are the same because ray by BD bisected angle CBE. Does that make sense? Now, we can mark that on our diagram, right? I could go like this. I could put a little mark through here like that on my diagram, and that would tell me that angle CBD and angle DBE are congruent. Or I could even do this. Watch, I could put a little single hash mark there and a single hash mark there. Remember I showed you those? And that makes it really clear to me when I'm looking at this that those two angles are equal, okay? Now, this might be the first time that we've seen this symbol too, but if you didn't know, this symbol right here, I wanted that to be a little squiggly, but maybe it's not going to let me. We'll see. This symbol right here means perpendicular. This is our notation symbol for perpendicular. And if you recall, perpendicular lines, right, our perpendicular bisectors that we've been constructing with our synthetic math, right, are two lines that meet to form two congruent adjacent angles, or I could easily say that, two lines that meet to form a right angle or right angles. Okay, so ray BC, so find ray BC. You see it? Find ray BA. Okay, ray BC and ray BA make a right angle because they are perpendicular. So now I can come up here in my drawing and I can put in a right angle marker, which is even more helpful for you because now I put another number in your pocket. What number did I just put in your pocket? 90. Now you have a 90 number in your pocket. Okay, so now you have a 90 number in your pocket, and if you happen to know the angle of CBE, that's another number you can put in your pocket because all you got to do is take it and divide it by 2 because it was bisected. See how that works? Okay, so this is the language that you're looking for, the symbols that you're looking for in these questions that are going to provide pieces of information for you to help you be successful. Part plus part equals whole for angles. All right, how'd we do? Everybody good? Feel confident? Okay, so your homework and the remainder of your time here in class is going to be to complete all of the questions that we did not do here in class, all right? And that's going to be due when I see you on Friday morning, all right? So I will leave you to do some work. I will go through and reveal all of the rest of the questions on here, and then you're going to complete this classwork for your homework assignment that's due Friday morning at 8:30. Everybody good? All right, rock and roll.